two major companies doing surveillance of dams that probably aren't moving now because one of the failures gone. And they've got lots more. They've doubled the number of piezometers. A typical tailings dam will have, by way of monitoring, will have, if you're lucky, piezometers, which are usually manual. They're not automated. They're usually recorded by people on site, but the data is sent to a consultant who might eventually get around to doing something with it. There's no reason in the world why those piezometers, there should be more of them, and they should be automated and directly linked, automatically downloaded, against and checked against trigger levels. Geotechnical triggers, safety triggers, should be automatic. The mine should have access to it, and the consultant, if they're using a consultant, should have access to it as well, but it should be all automated. I can't think of apart from Samarco, I can't think of a single tailings dam where that exists. Settlement monitoring or defamation monitoring of tailings dams, it's almost non-existent. Oh, it got buried in the last raise. Yep.
Should it be public?
The reason I hesitate is because NGOs are now very well-funded organisations, and they will use information to their own ends. So the mining industry is reluctant to have information published or made public because of the way it's misused. But I think you can turn it back on the mining industry and say, well, you haven't stewarded your business well in the first place, which is why you're a target. So they need to address that. If they address that, then I think they should make it more public. And I think they might do the NGOs out of the job. Because quite frankly, they're in the business of pointing out environmental poor performance. That's their business. If the performance was better, they'd have less of a business. That's their business model. They don't want to work with industry to make it better. But let's pose a question. Let's say you've got a tailings dam. Let's say it's in a country that's fairly flat, like Australia, and it's 10 kilometres long. It's a perimeter dam. It's 10 kilometres long. How are you going to instrument that dam with some of the devices we've been talking about? How do they compare with what you might do now, which is not very much, but piezometers and maybe settlement plates occasionally? And what would the cost be? And set that cost against the risk if you don't do that and you have another failure. So, anyone want to hazard a guess? What sort of instrumentation would you use for a tailings dam? You want to know its deformation. You want trigger points. You want to know the phreatic surface, the water level within the dam. So you need piezometers of some sort. And they tend to be spot ones. But you could also look at deformation, which could be more continuous. And you'd be looking at rates of change of deformation over time. There's a marketing opportunity for someone with the instrumentation that might do that. I mean, Samarco's spent a fortune. They're not operating anymore. They might eventually operate again. Putting all sorts of instrumentation in to monitor a non-operation. It's crazy. Why aren't we doing that with operations?
I suppose your question is quite right. And isn't the issue that you're raising precisely about the so-called distributed monitoring, distributed sensing of the entire sort of perimeter, 10 kilometers perimeter of a dam, an issue? That's the first point. We don't have sensors. The systems that you have, the piezometers and the settlement monitors that we have, they point locations that you monitor here, there, and it's at the judgment of the geotechnical engineer on site. So, well, I'm going to put this thing here, maybe it works out. But as Samarco demonstrated, it actually failed where there was no monitoring whatsoever.
There was monitoring.
There was monitoring. Okay.
They didn't read it very often. It was there.
Can I link these points to two that I want to make? First of all, precisely the very point that we began the conversation with about the way we mine. We mine, and Samarco is an example, the iron ore that was extracted there is not obviously very high grade, so they actually have more waste material than mineral. So it's because, of course, the margins of gains of the operations decrease. The solutions for mines is that to increase volume and increase large amounts of that reagent to make BHP or the value. So increase production to millions of tons per year more than expected in a different cycle. So that puts a lot of pressure on these systems such as dams and so forth, and now have to pretty much contained with more material than otherwise. So the way we mine is an issue. We actually have the wrong reaction to the change of cycles of mining, and we should not actually be mining for increasing volume, but rather select technologies that can actually have less waste reporting to the dam. Now, but I want to link this to the difficulty of monitoring extensively fine dimensions of a particular volume of rock mass or tailings dams, to what I think was raised here by Professor Gang as well, the unreliability of a fiber, for example, breaking in a borehole, and then we lose information over time. So, but yet, photonics are quite useful to pretty much measure conditions in certain unwanted circumstances or very difficult ones. Isn't the solution now to also question Professor Tongyu Liu about the so-called cheap materials for photonics that have an ability to pretty much not being linear measuring parameters, being volumetric measurements, and maybe a elastoplastic photonic system, whatever it is that you can call it, I don't know if it exists, but that will be a solution. But in addition, that being sort of balls of materials or equipment you leave there, that they can communicate through the ground systems, and that will be a good solution. They can move up and down wherever they are, as long as they can communicate. So that would be a good idea for you to explore. I talk too much.
I'm not sure I catch all your questions. But, so for the tailings dam monitoring, clearly the fiber optic sensors has demonstrated being useful. In China, hundreds of tailings dams being monitored by fiber optic displacement sensor, pressure sensor, water level, and so on. However, it does have that has the advantage of compared to electronic gauges because of it's reliable towards the light and storm. Right? So that is good. But talking about the user-friendly fibers like polymer fiber, while the fiber itself is good for connection, but currently I don't think there is a good sensor to use that type of fiber. So I think that is, and also plastic fiber can offer large deformation, unlike glass fiber. And so that is good for short term, maybe temporary, relative measurement, but not as an instrument, for long term. I think there are still lots of work to be done. Yeah.
Okay. I guess we're coming to a close, so I'll just make a few comments. In terms of plastic, you've got to deal with the fundamental material properties. So you have CH bonds, which means your transmission is going to be quite low for a long distance. So the kind of applications that you're talking about in the world plastic won't work. So in terms of new technologies for mining, I'm aware that there's a consortium overseas, and I don't know if it's a publicly listed one, but they're looking at laser drilling. And so laser drilling is a hot topic, so to speak. And that may have the advantage of selective melting of rocks if you want to minimise and target better mining. So they're kind of new areas, but we are coming to a close. So unless there's another question on a different topic that's of interest to the broader audience, we should wrap it up. There is one up there, so right up the back there. Is there a microphone?
Thanks. It's a good distance walk around. I just have a question in terms of the existing IoT and the lack of understanding of the data connected through those equipments. So IoT definitely has a lot of advantage of monitoring mining systems in a large scale, but at the same time, a lot of data has been monitored. It's not coming down to application. or decision making, which might be the case for Smartphone talked by Professor Williams. So what I'm wondering is that even having the IoT there, how the policy could be affected by that, so that the IoT is not a machine that just generates data graveyard.
That brings the topic, I guess, of artificial intelligence and managing all that sort of stuff. Perhaps even small data can be more important at times.
I mean, to answer your question, it really comes back down to what we were talking earlier about automation, because as we work towards automation, it's using the data, it's using the information to make decisions and take action. And I think that there's a couple of whispers here about the fact that it's not artificial intelligence, it's intelligence of just using the information that we have. So can you codify it, turn it into policy? Very difficult to do. Very, very difficult to do. And it comes back down to automating sequences, systems that will allow us to take away that waste and efficiently work our way through that big data. And there's a lot of information that's out there now. It's understanding what's important and what's not important. The automating cycle makes that happen. So I think that's an important aspect of it. Not quite sure if I've answered your question.
So what you mean is the data connected to IoT can only be responded automatically rather than by a decision made by human.
Yeah.
So if it's human decision, it tends to be rather delayed.
Yes, it's either delayed or forgotten. Somebody moves from position to position and the data information banks up. It's very, very hard to turn process and maintain process through individuals when you have human interaction. It is very hard. And what we're seeing here, I think, in every speaker that went through today, really talked about technology, and technology is taking us to another place. And I think it's really taking people out of the decision-making process.
Can I add a comment to that? I think there are some fundamental underlying issues that make short interval closed loop control of the mining process more challenging than it is in, say, manufacturing. Manufacturing solved this problem with MES systems 30 years ago. Now miners say, well, a mine isn't a factory. And that's to some extent true, but it is a process plant. And it could be better controlled with those, closed loop control systems. I think one of the issues, and it comes back to something that Professor Tongyu Liu said in his talk, is about standards and the interoperability that those standards can deliver that then enable those what are currently slightly disconnected processes down the mining value chain and make those more interoperable. And I don't think they are as well integrated or as interoperable. So I was very interested in your comment in your paper that you said that the government mandated the use of certain safety-related technologies. Now, in Australia, we've had debates going on for, 5 years about whether we should have some standards, let alone implementing those standards. Okay, well, I'm afraid we've concentrated hugely on mining today, perhaps at the expense of several other more, equally interesting topics. We'd have to use that for another evening. Thank you very much for your attention. I hope you found it interesting. Thank you to my colleagues who I think have done a sterling job. We are 2 minutes over, so I'll hand over to close the session. Thank you.